Hello everyone, welcome to Geeks for Geeks Python channel, and I welcome you all to this live session. So let me just test the audio and video once. Hello everyone. Yes, so it is working fine. So the topic for today's live session is sockets in Python. As you would have read from the thumbnail and the title for this video, it is socket programming in Python. So sockets is a fairly advanced concept in Python. Uh, so how we have structured this session is we will describe what are sockets, what are their use cases, and then we will implement a very basic example of sockets on our local machine. Okay, so let's get started. So the first question that should come to your mind is what are sockets? Okay, so you would have seen sockets at your home, right? The electrical sockets in which your plug in which you plug the appliances, right? So you have sockets like this, and then you have a plug, right? So this plug you will fit inside this socket, right? Socket and plug. So this plug goes inside the socket, and then your appliance is appliance starts working, right? Same way, we can use the same analogy of the electrical sockets and plugs in Python sockets. So what is a socket? So socket in Python is basically your client and server architecture for communication, between obviously client and server. If you know what is a client server architecture, very good. If you don't know what is a client server architecture, so I will explain you in very brief. Okay, so just remember socket is it gives you the usage of client server architecture for communication between client and server. So now we'll understand first in very basic what is a client server architecture. So you have a server, okay? Now what is this server? This server is just a machine, or you can say a system, okay? And what we do on a server is we run some programs. So this server runs some is running some program, and we have different clients. So client number 1, then client number 2, then client number 3, client number 4, client number 5 and 6, and it can go on. You can have n number of clients. Okay, now what this, so in very basic, what is client server? client will connect with the server and the server will respond. Now, why does clients connects to the server and why does server responds? To exchange information or to exchange data, right? So this client is also basically some program. For our explanation, I'll just say some Python program. And this server is also, so these are basically, client is basically your uh, end user, right? If you see in terms of usage, it is an end user which requests some information from server. Now server, as I told, is running some program, right? So server is running some program and it handles these requests based based on what is the logic inside this program. So this server is running a program, right? Now whatever request comes from client, first client will connect. All the clients will connect based on when they are using uh, something, when they want to use the server, right? So when they want to use the server, they will just request, they will first connect and say that I am connecting with you and I want this information. Now based on the logic written in the program which is running on server, server responds to the client back with the information. Okay, so that information can be handled by the program running on the client side, okay, or the script which runs on the client side. So there is one script which is hosted on server machine and there is one script which basically initiates the connection and then handles the response from the server. That's how the connection is made, established and handled. Okay, so it's basically, in a nutshell, it's an exchange of data, right? based on Based on how client wants and when client wants that information. Okay, so these clients can also be different systems. Okay, these clients can be mobile devices. So anything, it can be any machine which is capable of running and executing some code. Okay, okay. So you run the client, the client requests information and server responds. So this is how the client and server architecture is created. Okay. Now if we come to the socket analogy, so this plug is basically your server and this socket is basically your server and this plug is your client. Okay, the plug is client. If you want to take analogy from this example, the socket is where the plug is getting fixed into the socket, right? So different plugs, there can be multiple plugs. So like I have client 1, client 2, client 3, client 4, client 5 and client n. So there can be multiple appliances, right? An appliance can be your fan, an appliance can be uh, an appliance can be a tube light or a CFL or whatever. It can be anything, motor, anything, or your charger. So all those devices which have a plug, which have a plug interface, uh, uh, you can consider or you can imagine them as client. And the socket, the electrical socket where the plug is getting fixed, where the plug is getting uh, uh, where the plug is fixed, that you can consider it as server. Okay, so server has electricity. Here server machines are running some programs. Okay, so electricity and some programs. This can be an analogy. Okay. Now what that plug needs, that electricity. What the client needs from server, some information. So plug will come, it will fix, it will get inserted into the two plugs, which is the connect request, okay, and then the server will respond with the response. Okay, so that is the electricity flowing from uh, the socket to the plug endpoints till to the device, right? So this is the complete analogy between sockets and client server architecture. That's how the name is very self-explanatory, sockets, because it gives from this electrical circuit analogy you can understand client server architecture. Okay. Okay, so now what is, how do we implement these these client server architectures? So now we will discuss that. So as of now, for today's tutorial, what we will be doing is we will be implementing a client. We can implement multiple clients as well, but we will be implementing a client and we will be implementing a server, and both of them will run on the same machine, run on the same machine for testing. Now ideally these two are different, right? They both run on different devices. Server is running on a separate machine, client is also sending request which is different from server, right? It is a different machine, system, PC, mobile, whatever the appliances, right? So it both are running in application, in real world scenarios, both are running on different devices. But for the sake of testing and for sake of realizing the code, we will run it on the same machine, which is our desktop or laptop, or on whatever device you're implementing the code. Okay, but ideally these two are separate machines. Okay, but for testing and to realize what a client and server is, we will be running the code on the same machine. Okay, so now now there are some parameters. So this client has an IP address, which is basically the IP address assigned by your router, assigned by your router, right? And this client will have the IP, will have access. Okay, now there is IP address of server and there is port on which the socket service runs. Okay, so there are two parameters, and on the client side this information of server's IP address and port is provided, so that client knows that this is the address of the server, so it has to communicate with this IP address and on some port. So services are running on some port, right? Your HTTP service runs on HTTPS service runs on port 443, right? So there are some ports which are reserved on your machine for for specific purposes, right? You can read more about ports and stuff. So it is basically a concept of networking. So I won't go in details about the concept of networking. So for understanding the sockets and client server architecture, you just understand that there is a IP address associated with the server, and there is a port which is a port of the server machine which is designated to run this service. Okay, so now client will have access to these two information, access to servers IP address and port. port information, right? So server is running on server has an IP address and it has a port on which this service is running. Client has the access of this information, so client can connect using this information and the socket API. Client can connect with server, and then server can from the connect request, server can access some data and send the response. Okay, so ideally the most important thing for you to note is that client is present on a separate machine and server is a separate machine. For testing purposes, we will be implementing both on the same machine, but they are different machines. Okay, now we will also implement it on different machines. We will also see the case in future tutorials where server is different and server is a different machine and a client is different machine. But as of now, for today's tutorial, which is a basic introduction to sockets programming, and we just want to see how clients and servers are realized in Python programming, we will be running on the same machine. Okay. So let's get with this information, with the information of client server architecture and some basic informations, we will jump into the code section or the realization part of the tutorial. Okay, where what we will do, we will implement a client server code, right? Basic client server code. So let's get started without any further delay. I will open my editor, which is Visual Studio. I'll zoom in a bit. Okay, let's get started. So the first thing that you need is the socket module. So I will import the socket. Next you need is threading. Now why uh, don't get scared with the threading concept. I will explain to you why threading is needed in this. Okay, so we import the socket for implementing the for having the access to the socket API. Socket is the module, which is an inbuilt module. You don't have to install anything. If you have Python installed, socket is already installed. Threading is also pre-installed, so you don't have to install anything. Okay. So now this what I am writing the server part. Okay, we will write another script which will be client part, but as of now let's just focus on the server part. So now I'll define a port number for sake of simplicity and to be on the safer side. I am choosing the port number as 5050 because some ports are reserved on your system to run Windows and services for running Windows services. Okay, so I don't want to mess with those ports. So for simplicity, I'm just taking 5050. Okay, and you can have you have maximum of up till like 65,000 some number. You have ports till that number. So I'm just choosing 5050. Okay, port number 5050. Okay, now I am defining one more variable which is called header, and this is basically I'm choosing it as 64 because when you okay, so in this architecture, when the client sends some information to server has to respond back, right. So what it is doing is it is sending something, right? Client is sending something to server. So you can send some X amount of data in one time. Okay, server has to know exactly how much the client is sending in terms of number of bytes of data, right? So this header is basically that client can the server is expecting client to send 64 bytes of data in a single communication. Okay, in a single communication request, server is expecting the data packet which is of size 64 bytes. Okay, so this is what uh, this is the headers function. This is for that purpose I have chosen header to be 64. Okay, now I will define my server. So socket dot get host by name, and inside this I will do socket dot get host name. Okay, so now what this will do is, so if I'll show, so we need an IP address of server, right? So if I go to command prompt, and for my system, if I just give IP config, so this shows me my IPv4 address, right? My IPv4 address is 192.168.0.84. Okay, on my the router has assigned me this IP address for my system, right? So my device is having address 192.168.0.84 on my local network, right? So that address is basically stored in server. So if I just print server, server. So if I'll just print server once, okay? So save this module as, so I'll save this as server.py. Okay, I'll save this. Let's run this and see what it prints. cd desktop, cd tutorials. I'll zoom in. Now if I run py server.py, see, so it prints 192.168.0.84, which was same as my IPv4 address, right? So this is to get the IPv4 address. We discussed this IP address of server, right? So this is the way to get that IP address. So I'll get rid of this print server. Now server is defined. Now I need a tuple of this server and port. I'll create a tuple. So this will be used to in further code. We'll see where it gets used. Okay, so now my server object is getting created. Socket, I'll create a server object. Socket, and in these, while creating the server, I will pass two parameters. So first one is socket.af underscore inet, everything in capitals. Okay, and the second parameter is socket dot sock underscore stream. Now what are these two parameters? So this af.inet is telling you to use the IPv4 address as a convention for creating sockets. Okay, so this is that parameter. You also have inet 6, which is for IPv6. Okay, so this is socket. So this is the first parameter. Second is socket.sock stream. So this basically tells that we will be streaming the data. Okay, so that is basically the purpose of these two parameters. Now my server object is server variable is created. So now I'll just bind to my server variable addr. Okay, so I'll bind the IP and the port to my server variable. Okay, so binding is done. Now I'll also declare one more variable, which is format equals UTF-8. Now what is this format? Because client will be streaming the data in bytes. It will stream data byte wise. Okay, so as we have defined, it is a header of 64. So 64 bytes of data byte wise it will stream. Okay, that is why we have used socket stream. So it will stream 64 bytes. Client can send 64 bytes at once. Okay. Now these bytes, client will send the data in byte format, but I will need on the server side to understand and create logic. I need it in the string format, right? So that is why I'm using UTF-8, because from UTF-8 byte from UTF-8 byte kind of convention or data type, I will convert it into string. Okay, so for that purpose, I am using format as UTF-8. So this will get clear once we execute. Okay. Okay. So now, as we have seen, we have used the threading, right? So let me just create two methods and we will understand the usage of these two methods in a short while. Okay. So I'm declaring two methods. First is handle client, and I'm passing two uh, sorry, comma, first is connection, comma, addr. Okay. So I am just writing pass. Okay, this is my first method. And in the second method, I will just start. Okay. So this is my second method. Now, why I am using threading? Okay. So we'll understand that. So you must have, if you have read about thread, it's very good. If you have not, I am giving you a very small example. Okay. Why do we need threads? So let's say you have a program where the first line is import time. Okay. Then the second line is time dot sleep for 60 seconds. And then you have a print statement. Print print 1, 2, 3. These three lines are there in your Python file. This is the code you have written. Let's assume you have written this code. So first line is import time. Second is time dot sleep for 60 seconds, and then print 1, 2, 3. So when you execute this file, import time will be executed, and then because of this time dot sleep, your program will be in blocking state, because you have given the sleep command, right? So because of the sleep command, your program will go in blocking state. It will not do anything during that time, right? During those 60 seconds. And then after 60 seconds are over, your print 1, 2, 3 will be executed. Okay. Now what if you want print statement to happen simultaneously while this time dot sleep is given? You want the program to to wait also for 60 times, but you don't want this print statement to be executed after this 60 seconds are over. You want to simultaneously execute the print statement. So then you can use threading. Okay. Now how this threading will help? This print statement you can execute in some new thread, and this time dot sleep is already executing in your current thread. Okay, or your current process. So that is the use of threading, right? You can run multiple codes, uh, and these codes will be independent of the current thread in which your program is running. Okay. Now why are we using threading in our example? So the basic simple logic is, there is server. Uh, Let me draw this here. So now we'll understand why do we need threading in our example. So there is server, right? Now let's say you have client 1. Okay, this sends a connect request. Now this will respond. But you can have multiple clients, right? Now this connect response will take some time. So let's say this client has sent this connect request to server and it sends a response. Now let's say this whole process is taking 2 seconds. But you have several, you have client 2, you have client 3, you have client 4, you have multiple clients, right? Which the server should also handle. It cannot wait, it cannot execute for, it cannot first process client 1, then after client 1 is done it should process client 2, then after client 2 is done it should process client 3. No, then it will be forming a queue, right? So we don't want that queue. We want the server to respond to all the clients at the same time. Okay, so that is why we need threading in this, so that once the server is initiated, all the clients in different threads can be handled. Okay, our server is not blocking other clients, so that all the clients are getting served and all the clients can reach the server at the same time. Okay, so if client 1 is taking 2 seconds, and in those 2 seconds client 2, client 3, client 4, all of them came, so then it will not work, right? Because first it will wait for 2 seconds, first it will serve client 1, then it will move to client 2, then again it will take 2 seconds or 3 seconds, whatever client 2 has requested, then it will come to client 3, then it will again wait for 2 3 seconds, then it will go to client 4. We don't want that. We want the server to be responsive to each and every client, because they can, multiple clients can connect to server at the same time, right? So that's why, for that purpose, we are needing the thread. Okay, and I already told you what is the purpose of thread. Okay, so this function is handle client, is basically for handling the multiple clients in a thread. Okay, and this start is basically to initiate the thread. Okay, so now I will just write, let's just complete the thread, the start function. So server dot start, server dot listen, so that it starts listening. Now I will go in a while loop, because server has to continuously listen, right? So so now I'll create connection comma addr equals server dot accept. Okay, now what is this connection addr? It is client related information, okay, based on which server will identify, okay, this client is coming. Okay, now I'll create a thread thread dot thread. Okay, and inside this I pass the target equals, let me zoom out a bit, target equals to, so for this thread I want to execute this function, so I'll give target function as handle client, comma args for this function is so handle client takes 2 arguments, right? So I'll give those 2 arguments, con comma addr. I'll close the thread. So it is taking a connection and an addr, right? So we have already got con and addr from server.accept. This is where the server is accepting a client request. Okay, so from when it accepts the client request, it comes to con comma addr. I mean, you get two values. This you pass as the arguments to your thread's target function, okay, which is handle client. Target is handle client, this is a thread, so that it can execute multiple clients at the same time. Now I'll just start the thread. Okay, so thread is started. Now I'll print something. So print active, because I want to see how many clients are there, right, currently. So active clients equals active clients equal, I will use the f string dot format, and inside this I'll use threading dot active counts. Okay, -1. Okay, now why this thing threading dot? So I want to count how many clients are connected at a particular time, right? So the number of threads that are active -1, because one thread is already, this is where the server is running, right? So I have subtracted 1 from that, and the count of number of threads will give me the number of active clients. So that will give me the connected number of connected clients, right? Okay, so my start is done. So just to start things, I am giving another print statement, server server, let's say starting. So this is the initial print statement. Okay, and finally I'll call the start method. Okay, so I am listening. I have asked the server to start listening, then the server starts to accept, and then once it accepts, it runs every client in a thread. Okay, it handles every client in a thread. So now what should be handled in the thread? Now each client will run in a different thread, right? So I can have multiple clients. Okay, that functionality is achieved using threads, and number of active users I get by active count. Okay, now inside the handle client, what I need to do inside handle client? So what is client doing? Client is sending some message, right? Client is just sending some message. So now what should be done? So first I'll print. So on the server side, I just want to read what the client has sent, right? Based on that, I'll do some processing. But as of now, we'll just see what the client is sending. Based on that, you can do anything. Okay, you can write logic to do anything. So inside, when the connection is accepted, I will print new connection. So this is my target function for the thread, right? Once the connection accepts, the thread will be called, and the function given in the thread will be called. So new connection connected, I'll write. Okay, and then I'll print some details from about the client. So I'll use the f string dot format, and I will give addr. So addr gives some information, holds the information about the client. So I've used addr. Okay, now I'll give connected. I'll create a variable for the while loop, connected equals true. The exact implementation of this connected variable we will see in the next tutorial, but as of now just understand that I am using this connected logic for my while loop. Okay, while connected. Okay, as long as the clients wants to stay. Okay, message equals. So now my connection, from the connection object I will call the receive method. Okay, and inside that I will pass the header. Now header is what we have defined, 64 bytes, right? So it should receive 64 bytes from the connection which was established. Okay, now dot decode. Now as I told you that the client will send the information byte-wise, so I will have to decode it in string format. So for that purpose I am using dot decode format, which is UTF-8. This will convert my message into a string. So if message is not empty, okay, just print message from client dot format message. So I'm using a f string, I'm just printing the message. Okay, so this looks good. I'll save it. Okay, so what we have done, we have used the defined the port number, the header, number of bytes we want to receive from the client. We created the server address, then we created an ADDR object which contains the server address and port, created the server variable, we binded the address and port to the server variable, we created a format for encoding of bytes into string, we have a handle client which is the threading target method, and we have a start which is basically the starting point, right, to start the thread in which the server is executing, right. So I accept, and as soon as I accept, I pass it to my thread function so that every client is handled in a different thread. Okay, and multiple clients can connect. Okay, so this looks good. We have implemented everything. Now let's create a new file where we will write the client code, right. So I want an empty module Python. Okay, so this is, let's save this first. So I will save it as client.py. Okay, okay, so this is saved now. Okay, now what I need in the client part, I don't need anything specific, I just need socket. Now this is the program which will run on the client part to send the request or to send the data uh, to the server. So what we are doing in this, we are sending some message to the client, to the server, and based on the message received on server, you can write logic, right. We are not writing any logic, we are just receiving and sending the message as of now. We will explore everything in the future tutorials as things will complicate from here. Okay, so port is 5050, format is UTF-8, right. So to encode the strings into bytes, I use the UTF-8 encoding, right. So now I will have to provide the server IP address. Okay, now the server IP address, it should be hard coded on the client side. Okay, because see why I used I could have used I could have hard coded the server on my server side as well, right. If you see, server on my client side is defined like this, whereas on the client side it is defined like this. Why? I could have just used a string also, but why I have defined here is because when you run it on a different machine, it will change based on the network, right. So that's why I have not hard coded it. But for the client side also, you should write the same value which you get after executing the server. Okay, you can do the same thing on your system for server files, but the client should exactly know what is the server, right. So client, I am just hard coding it. Okay, for client it will, the server will not change. For server it can change, that I might have a requirement that I need to change the server IP address. So it should, and there can be a requirement where the server, uh, this code is hosted on some other machine. So then that's why I've used the coding coding part to get the IP address. On client side it is fixed, right. So that is why you can also hard code it. I mean, you can, on client side you can just hard code it. Okay, okay, so now I'll create the same ADDR using the the ADDR tuple using server and port, right. Okay, now I will create the client object. So if you see in the server, I created a server variable, right? Now I'll create the client. So for that, client equals socket dot socket, and inside that, same parameters as defined in the server. So same parameters inside client. Okay. Now I will give client dot connect, and inside the client dot connect I'll pass ADDR, which is a tuple. Okay. Now the connect is done. I need a message to send to the client, so I'm giving the same old message, hello world. Okay. Okay, now I need, this is in string format and I need it, the client will send it bytewise, so I need to encode it, right? So message dot encode uh, in, and I'll pass format, which is, format is UTF-8. Okay, now my message is ready to be sent bytewise. Client dot send, and I'll pass the message. So I'm keeping the client very simple. All the complexities we'll see in later tutorials. It will obviously get complicated from here, but for the sake of today's tutorial, we're just establishing and seeing the communication, so I'm keeping it simple. Okay. Okay. Okay, so this much is done. Okay, let's take input, so that I need to press enter to send another message. So client dot send, again let's send the same message. Okay, so let's save this much. So what I'm doing, I've used probably the same code which was defined in server, just the method is different. Client dot send and client dot connect. Okay. Here we use server dot accept method, right? Because server has to accept and client has to connect. So client dot connect. Okay. So let's execute server on one of the command terminals. So py server dot py. I think it is visible. Okay. So I've executed. It prints server starting. It has already started. Now, if you see, it is in a while loop. It is waiting for clients to connect. Okay. So I'll create one more terminal instance. Here I will call the client. Here I will execute the client. So that is why it is on same machine, right? Py client dot py. Okay. So it is saying name message. It is giving an error. Message is not defined. And it is saying in my server file also threading is not defined. Okay, I have made a spelling mistake. So okay, so it is not capital T threading, small t threading. Okay. And the error on the client side was message is not defined. So okay, so this is MESAAGE, MESSAGE. Yeah, now everything looks fine. Let's reduce the size so that we can see things simultaneously. Okay, so this is my client sorry, this is, yeah. So these two are my terminals. Here on the right one side, I will run the client. On the left hand side, we will run the server. So I'm giving py server dot py on my left side, and it prints server is starting. On the right side, I'll execute the client. Okay, client dot py. Okay, it is giving one more error. So it is giving dot format threading dot active counts has no, threading has no module or no attribute called active counts. Okay, so it is not active counts, it is active count. Okay, so I'll just close this. Okay. So I'll go to my server. So this is not counts, this is just count. Okay, save it. This is my right side is my client, left side I'll run my server. Okay, so cd desktop, I'm navigating to the folder. Let's run once again py server.py. Okay, it is printing started. Now I'll run the client py client.py. Okay, so as you can see, it is printing message from client hello world, right? It is printing new connection connected, printing the IP address and the ADDR of the client. Okay, active clients equals to 1. Okay, and message from the client hello world. So it has executed till this line, till this line. So I created a message hello world, message is encoded and client has sent. Now it is asking for an input. Okay, so I will yes, so I will give some message. So I'll just print enter. So it printed message from client hello world, right? Yes. So let's execute once again. So cd desktop, cd tutorial, py server.py. Okay, not surf, cmd. Okay, it has started. I'll execute the client again. Yes, so it again prints the message from client hello world. Then again, it was on the client side, it was waiting, right? Let's execute once again. See, when I executed client.py, it is giving active, it first it gave active client equals 1, then it gave message from client hello world, then it was because on the client side I gave an input and I pressed enter, it again after that printed hello world, right? Then after I executed the script again, now the active clients have increased to 2, right? Because this is my second client. Again, if I press enter on the client side, it has printed hello world, right? So that's how you can see that I have multiple clients communicating to my server. Okay, it has, my command prompt has glitched for some reason, so that is why it is not coming. So if I execute once again, py server.py. Now if I execute the client, see it gave new connection connected. This is the IP of the client because they are running on the same machine. Active client is number is 1, message from client is hello world. Okay, now my client is asking for an input, so I'll just press enter, and after I press, so after it is asking for input, I'm again sending the same message from that same client. So it is saying, so the second hello world is received and the active client is still 1, right? Because it is only one client has connected. Now if I give one more time, it is not taking for some reason. Maybe because I have not closed the connection, the existing connections. That is why they might not be taking this. py server.py. Okay. So now it prints. Okay. Yes. So now it is printing. So I executed py client.py 2 times. First it printed active because in my client I will send the message 2 times, right? I execute the client.py script once, it should send 2 messages, 2 times hello world. So that is what happened in the server side. If you see on the server side, first when I executed client.py, it said active client equals 1, message was received from the client hello world. After the input I pressed enter, so input contained nothing, it's just an enter thing functionality. So message from client hello world. Then again I executed the script, it said new connection connected, right? Because it's a new connection, so that is why it is printing new connection connected. If you see the server.py, when a new connection thread is started, then only your handle client will get executed, right? So now this server is not waiting for this client to finish, it can serve multiple clients in at once. Okay, so it will serve all the clients in parallel. So all the clients can get connected to this server at once. And then when the second time I executed the client, it says now the active client became 2. And then again it received the 2 hello world, which was sent by the client when I executed client.py second time. Okay. So this is how you create sockets. It is a very basic implementation of sockets. We will go in depth about sockets, and we will learn how to open a connection, how to close a connection, how to handle these. I mean, we have already seen how to handle clients, but we will obviously implement a much more efficient way than this. This is uh, creating some troubles, so we will definitely do better than this. In next class, we will see, in next tutorial, we will improve this handle client thread, and we will also study about this header thing, because this is very important. So we will study about this header concept, then we will study and improve this thread function which is written, and we will also improve the client side. Okay, and then we will see how our socket example looks like at the end. So for today's session, the takeaway was the architecture of client server, right? The architecture of client server was important. Then all the parameters that are used in the socket are important, like IP address, port, and this concept of threading was important, blocking state, and we also we also implemented threads in some way or the other. We also implemented a thread, right? So we studied a lot. There was a lot of takeaways from this session, like threads, the usage of threads, why we need threads. We also saw its application in client server example in sockets. We also saw what is client server architecture, and we saw how client and server, what are the different ways in which client server can be implemented, whether on same machine, different machines. We also saw sockets analogy and everything with the electrical plug thing, right? So I hope this session was useful to you in some way or the other. We will continue with our discussion on sockets in our next class, next tutorial. So keep learning, and do share this video, like, share, subscribe to our channel, like the video, share this video with your colleagues, friends, workmates, and just it will be really helpful if you share this video, because that basically motivates us in the long run to create content like this for you guys. And yeah, so I will see you in the next one. Until then, stay safe and take care of yourselves.